Welcome to my YouTube channel Math Sikshak. I am a mathematics teacher with 15 years of teaching experience. I have been preparing students for ICSE, CBSE and IGCSE board examinations. During this journey, I have realized that mathematics needs to be taught in a simple and meaningful manner. It is my endeavor to present a topic step by step in a simpler way. I have tried to correlate the problems with real-life examples in my presentations. My first video is Introduction to Exponents. My video has been divided into 4 parts: an introduction, followed by an explanation. Then certain questions have been solved step by step. And my final section consists of unsolved questions with answers given. For any clarification, you can mail me in mathsikshak@gmail.com. At the end of the session, you will be able to identify the bases and exponents, locate the laws used, apply the law of indices, and evaluate the laws in different situations. Let me start my presentation by explaining what is an exponent and where do we use it in our real life situation. Now, in mathematics, when we see, there are basic 4 operations: addition, subtraction, multiplication and division. Why is it called as an operation? It is called as an operation because it tells us what we should do with a number. Similarly, exponent can also be considered as an operation because exponent tells us what we should do. Now we have written this number in exponential form, 2 to the power of 3. So what does it tell us? It tells us that we should multiply 2 3 times. So it is 2 into 2 into 2. So 2 to the power of n means I need to multiply 2 n times. So it's 2 into 2 into 2 n times. Since 2 is being multiplied again and again, it is called as a repeated multiplication. So exponents are basically used to simplify repeated multiplication. Now, what do we see here? We see that there is a house. In architectural field, when I take, we use the terms square feet and square meter. These are the actual usage of exponents. When I say that my room measures 10 feet by 10 feet, it actually means I'm multiplying 10 feet 2 times. It's 10 feet to the power of 2. So in the field of architecture, the usage of exponents is very high. Proceeding further to the field of medicine. Doctors use exponents to figure out how quickly a disease is going to spread. Now what do we see here? This is a normal cell growth. This is a cancerous cell growth. Now when the representation of numbers are very high or when they are very small, it is very difficult for us to pace it out in a sheet of paper. At that point of time, we represent the numbers using exponents. So the usage of exponents is very high in any field we take in. Now when we write a number, we can either write it in expanded form or we can write it in exponential form. Expanded form means I expand the number and write. For example, when I take 5,000, I write it as 5 followed by 0, 0, 0. But this we could also write it in exponential form as 5 into 10 to the power of 3. So, how did I write this as 5 into 10 to the power of 3? It is 5 followed by 3 zeros. So therefore, it's 5 into 10 into 10 into 10. So 10 is being multiplied 3 times. So I write it as 5 into 10 to the power of 3. Now let us understand what are the various terms that we are going to use in exponents. The first term that we will come across is base. So what is a base? A base is the number that is being multiplied. How many times is the number being multiplied? Is called as the exponent. And then is the negative index. So when I write a number as 2 to the power of 5, the 2 is called as the base, 5 is called as the exponent. So that means 2 is going to be multiplied 5 times. That's 2 into 2 into 2 into 2. Now what is called as the negative index? When the power is a negative, then it is called as negative index. So if I take a number as 2 to the power of minus 3, so 2 is my base, minus 3 is called as my negative index. One thing we should remember, the negative index needs to be made positive and then we can use it for simplification. In my next slide, I will be explaining to you how a negative power can be made a positive power. Now let us understand the various laws that we use to simplify questions. The first law is called as the product law. So we can see that the bases are the same, then we can add the powers. It can only be used for multiplication. So a to the power m into a to the power n is a to the power of m plus n. So for example, if I take 25 into 125, it is 25 is 5 to the power 2 into 5 to the power 3, that is 5 to the power of 2 plus 3, that is 5 to the power of 5. Second law is the division law. It's a to the power m divided by a to the power n. So when I'm dividing with the same basis, powers need to be subtracted. It's a to the power of m minus n. So 5 to the power 5 divided by 5 to the power minus 2 is 5 to the power of 5 minus of minus 2. That's 5 to the power of 5 plus 2, because minus into minus is plus. So it's 5 to the power of 5 plus 2. That is 5 to the power of 7. Proceeding on to the next law, that is called as power. So already a number is expressed in exponent form, and when there is another power to it, so it's a to the power m whole power n is a to the power of m into n. So it's 5 to the power 3 whole to the power 2. It's 5 to the power of 3 into 2, that is 5 to the power of 6. So when an exponent is expressed with another power, then both the powers can be multiplied. Next, what we call as negative index. So negative index needs to be made positive. How do we make it positive? By taking its reciprocal. So a to the power minus n is 1 by a to the power of n. So negative, I made it positive. Only then can I simplify it further. So considering this example, 3 to the power minus 2 is 1 by 3 to the power of 2. 3 to the power 2 means 3 is being multiplied 2 times. So it's 3 into 3, that is 1 by 9. Now next is the law where we have the same power. So here the bases are different but the powers are the same. Power or index or exponent, it is the same thing. So a to the power b into b to the power p is nothing but ab to the power of p. So I can group them and write them as ab to the power of p. So 5 to the power 3 into 4 to the power 3. Powers are the same. So it's 5 into 4 whole to the power 3. That's 20 to the power of 3. The next one is the power 0. So when any base has power 0, that's equal to 1. So 2 to the power 0 plus 7 to the power 0 by 5 to the power 0. 2 to the power 0 is 1 plus 7 to the power 0 is 1 divided by 5 to the power of 0 is 1. So it is 1 plus 1 divided by 1, that's 2 by 1, that's equal to 2. Now till now that we have come across, we have only seen integers, that is negative and positive numbers which are not in fractions. But now when we come across, we will come across situations where we have a fractional power. So nth root of x to the power m is x to the power of m by n. That is nothing but x to the power m whole to the power 1 by n. So we can apply the power law and write that as x to the power of m by n. Now, in this case, we will come across certain mathematical terms which I'll be explaining further on. When we are able to determine the root, the square root or the cube root of a number, and we get a perfect value, then that's called as a rational number. If we see that the square root or the cube root of a number keeps proceeding on without coming to an end, and neither are the numbers being repeated, then that's called as an irrational number. For example, when I take root 2, that is 1.414213 and it keeps moving on. So it's never going to come to an end. That's an irrational number. Here, root 4 if I take, we get a perfect value, that's 2. Root 9 when I take, we get a perfect value, that's 3. So these are called as rational numbers and these are called as irrational numbers. So now, when we see that the power is a fraction, that is called as a surd mathematically. Now for example, what do I see here? I see there's a ladder here. This is resting against a wall. Its distance from the ground is h and the distance of the foot of the wall from foot of the ladder from the wall is d. So I can find the length of the ladder by applying Pythagoras theorem. L square is equal to h square plus d square. L is equal to root over h square plus d square. So what I can say about the value of L? The L can be a rational number or it can be an irrational number. So since the value of L can be written with an fractional power, it can also be called as a surd. Now let us look into the common mistakes that children usually do when they simplify questions on exponents. The first one is root over x plus y is not equal to root x plus root y. X plus y whole square is not equal to x square plus y square. X plus y whole cube is not equal to x cube plus y cube. Only when there is a multiplication or a division sign here can we separate it from the square root and write. A square plus a cube is not equal to a to the power of 2 plus 3. If it would have been a multiplication here, then I could have applied my law of exponents. Otherwise, it is not possible for us to apply the law of exponents. Now moving on to our next section, that is the solved questions. The first one here. 8 to the power 3 into 2 to the power 4. The first thing that we need to keep in mind is bring them to the same base. So 8, I can write it as 2 to the power 3, whole to the power 3. So exponent is, we are writing it in exponential form and again there is a power. So we can apply the power law, a to the power m whole power n as a to the power mn. So this is 2 to the power of 3 into 3, that's 2 to the power 9, into 2 to the power of 4. That is 2 to the power of 9 plus 4, again applying the product law, that is a to the power m into a to the power n as a to the power of m plus n. So this becomes 2 to the power of 13. Next question. So when we see there are two terms here, 4 by 216 to the power of minus 2 by 3 is one term, 1 by 256 to the power of minus 3 by 4 is another term. We will simplify them separately. So 4 by 216 to the power of minus 2 by 3. 216 is 6 to the power 3, whole to the power minus 2 by 3. Again, we can apply the power law here because it is exponent being multiplied with another to the power of another exponent. So it's 4 by 6 to the power 3 into minus 2 by 3. That is 4 by 3 and 3 gets cancelled. So it's 4 by 6 to the power of minus 2. We cannot keep it as a negative index, so we make it positive by taking the reciprocal. So it is 4 into the reciprocal of 6 to the power of minus 2 is 1 by 6 square. Therefore, this becomes 4 into 6 square, that is 4 into 36, that is 144. Now we are considering the next term, that's 1 by 256 to the power of minus 3 by 4. Now 256 can be written as 4 to the power of 4. So again we can see it is raised to another power. So we can apply the power law and write this as 1 by 4 to the power of 4 into minus 3 by 4. 4 gets cancelled. So it's 1 by 4 to the power of minus 3. Again, we need to take its reciprocal to make it a positive index. So it becomes 4 to the power of 3. 4 to the power of 3 means 4 is being multiplied 3 times. So it's 4 into 4 into 4, that is 64. So the first equation, we got it as 144 from the first term, and from the second term we got it as 64. So if we substitute it back in our original equation, so it will become 144 minus 64, that is nothing but 80. Now proceeding on to our next question. 3 to the power 2 plus 4 to the power 2 whole to the power of half. As I told you, when there's an addition sign, we cannot apply the law of exponents. So we will do it separately and then substitute it back there. So 3 to the power 2 is 3 into 3, that is 9. And 4 to the power 2 is 4 into 4, that is 16. So it's 9 plus 16 whole to the power half, that's 25 to the power half. That is 5 squared to the power of half. Again applying the power law, it's 5 to the power of 2 into 1 by 2, that is 5. Now, looking on to our next question. It's 3 into 9 to the power of 5 by 2 into 9 to the power of minus half. So to simplify, 3 into 9 to the power of 5 by 2 into 9 to the power of minus half. So our first main aim should be to bring them to a common base. So I bring everything to the base of 3. So it's 3 into 9 can be written as 3 to the power 2 whole to the power of 5 by 2 into 3 to the power 2 whole to the power of minus half. Again applying the power law, it becomes 3 into 3 into to the power of 2 into 5 by 2 into 3 to the power of 2 into minus half. So the 2 here gets cancelled and the 2 here gets cancelled. So it's 3 into 3 to the power of 5 into 3 to the power of minus 1. So 3 to the power of 1 plus 5 minus 1. So that's equal to, by applying the multiplication law, it is 3 to the power of 5. In our next section, we have few unsolved questions where answers have been provided. For any clarification, you can mail me at my mail ID mathsikshak@gmail.com. Thank you for watching this video. In my next video, I'll be solving difficult questions on exponents. If you want to follow me, kindly subscribe to my YouTube channel. Thank you.